Alright, so section 2.4 is about the second derivative. Now we have been talking a lot of the first derivative, which is the rate of change of the function or the slope of the tangent line. Now if I have a function f is a differentiable function, that means I have the derivative of the function, then its derivative is also a function. So if I can take a derivative of a function, that means I can take the derivative of a derivative. So the derivative of the derivative also is a function. And if I take the first derivative of the first derivative, I have the second derivative, or f double prime. So this new function notation is called the second derivative of f. And this is because it's either the derivative of the derivative of f, or if you use a Leibniz notation, we can write the second derivative as d squared y over the x squared. So remember, at the bottom, the variable x, the exponent also is always in the exponent of the variable x, and the exponent on the top is always in the exponent place of the letter d. Now I have a graph of the original function f prime, which is the first derivative, and f double prime, which is the second derivative. Now we can interpret the second derivative as the slope of the curve of the first derivative at a point x, f prime of x. In other words, it's the rate of change of the slope of the original curve. And here, if we take a look at the blue curve or the first derivative, so we see if we take the slope from this point to here, so from here to here, the slope of the blue curve is negative or decreasing or negative. That means when we take the slope of the blue curve, we get the second derivative should be negative. That's why the orange here is all in the negative value. Now if we take the slope of the blue curve at this point, is it increasing or is positive for the second derivative, which is true for here. From this point to this point is always negative, positive. So in general, we can interpret a second derivative as a rate of change of a rate of change, and the most familiar example of this is the acceleration, which we define below. I have a function f. S of t is the position function of an object that's moved in a straight line. Now when we take the first derivative, it will give you the velocity of an object, and if we take the rate of change of that velocity with respect to the time, we will have something called the acceleration function a of t, and a of t now is the second derivative of the position function. So remember, the acceleration is the rate of change of the velocity or the second derivative of the position function. And so on, we can have the third derivative by having the triple prime in the same notation here, and this process can be continued for higher derivative 4, 5, 6 and so on. Now what does the second derivative tell us? So remember from the graph before, if the second derivative is bigger than 0 on any interval, then the first derivative should be increasing, and we have the function f to be concave up. And in contrast, if the second derivative is negative, that means the first derivative is decreasing, or the graph of the original function is concave down. And take a look at this picture for easy visualization. If I go from left to right, my first derivative decreasing, so from negative go up to positive, right? So it go from decreasing to increasing. So if go from left to right, it's become increasing. That means my second derivative bigger than 0 too, or I have concave up, or it's open up the curve. Now if I go from left to right, I have the slope of the curve or the first derivative going from positive to negative or decreasing. So from I go from left to right, I have the first derivative from increasing going to decreasing. That means my second derivative should be negative, or I have concave down, or in this case my curve is opening downward. Okay, so one problem here. This is the problem from the textbook. Now I have a curve and there are 4 points indicated here, A, B, C, D. They want to ask us to make a label for the function f, f prime, and f double prime. Okay, so remember, this original function here is the function f. Now we want to identify at this point, and my first derivative and second derivative and the original function, they all have positive, 0, or negative value. So we need to determine those sides for the point A, B, C, D for the 3 functions here. So let's go over the solution. At point A, the function f is negative because it's touching to the negative side. At point B, it's up here, so the value of this function is positive. And point C, again positive because it's up here. Point D is negative because it's all the way below the x-axis. So this is true, easy. Now we want to consider the slope, or f prime. F prime is the slope or the derivative of this function at these 4 points. So if at point A, if we draw the tangent line, to point A, we're gonna get the tangent line up like this. Sorry, it should be horizontal. So this horizontal tangent line gives you the 0 slope. The same thing to point B. If I draw the tangent line at point B, this is also a horizontal tangent line, which gives you the 0 slope. So the slope at this point and this point is 0 for here and A and B. What happened to the slope or the derivative at point C? So point C, we draw another line. This is decreasing or negative. And point D, the slope here is increasing, right? It's going up now, so it's become positive. Alright, so the last thing is the second derivative. At point A, remember, in order to consider whether it is positive or negative, remember, f double prime, the second derivative, when it is positive, your function is concave up, or is open up. When it is negative, your function is open down or concave down, right? So if you take a look at point A, if we go from left to right of A, it's going from negative decreasing to increasing. That means it's open up, or the second derivative is positive. As point B, if we go from left to the right of point B, it's going from positive to negative, right? Positive to negative. That means it's going from increasing to decreasing. So it's decreasing, meaning that it's open down, or it's concave down, or the second derivative is negative. The same thing from C. If you go from left to right, C is going downward, so open down, or you have negative value for the second derivative. Now point D, we go from left to right, it's open upward or increasing. We have what? We have positive value for the second derivative. So that is the end of section 2.4. Yes, that's the end of section 2.4. Oh, there's one more example. Oh, sorry, this is not. Okay, so this is the end of section 2.4, the second derivative.